Today we're looking at our last topic, which is trapezoids, our last special quadrilateral. Now, again, we're not going to be looking at kites this unit. We did mention them on our first day because those shapes can sometimes pop up on SATs. But if you're one of my students potentially that needs to take the SOL does not have kites on there, so you're going to find that that actually does not pop up on our test either. So let's look at some trapezoid problems. And again, if you are looking ahead at the completed version of these examples, you'll notice that some of them have red stars next to those. Those are the examples that I'm going to leave you to try on your own, just to keep the video a little bit shorter, but we're still going to do an example or two of each type to make sure that you're good to go. So our two types of trapezoids that we have are regular trapezoids or non-isosceles trapezoids and isosceles trapezoids. And if you think about that word, well, what does isosceles mean with triangles? We have two congruent sides with isosceles triangles. So it's the same thing with trapezoids. We would have two congruent sides. Now on our trapezoids, the special thing about this is we only have one pair of sides that are parallel. In parallelograms, you have both pairs of opposite sides are parallel, not with trapezoids. We also need to take into account that if we only have that one pair of parallel lines, then we're probably going to see a little bit more with this on possible consecutive supplementary angles. So in our non-isosceles example, that would be the two start angles would add up to 180, or let me switch to a different, there we go, or the green stars, those would add to 180. But when we look at isosceles triangles, then we've got a lot more symmetry. Excuse me, isosceles trapezoids, it's easy to mix them up because we have a lot of the same notions. We've got congruent sides. So on our isosceles trapezoid diagram, you've got your two dashes on the sides for our two congruent pieces. And then that also means we've got a nice symmetric shape. So the diagonals are going to be congruent to each other. So the dotted lines in our diagram are always congruent. We also have the base angles are going to be congruent. Now, when we have trapezoids, we actually have two bases. So that sounds a little bit weird, but it's just the way that we refer to the parallel sides in our shape. So every trapezoid is going to have two bases. It's going to have the smaller base and a bigger base. Sometimes it's going to be flipped around, but it's always going to be those two opposite sides that happen to be parallel to each other. And in an isosceles trapezoid, the two base angles, the angles that touch the same base, are always going to be congruent. So we have our bottom angles here, our acute angles would be congruent, and our top pieces would also be congruent. And so we could actually match those up side by side if we know we have an isosceles trapezoid. So let's start looking at some examples. So our first three, we're going to look at some angles. So these trapezoids, again, 1 and 2 are just a plain trapezoid. Number 3 is an isosceles trapezoid. So let's see how these work. So in number 1, we have 87 degrees at angle J and 51 degrees at angle L. So the only thing that we could do with this is note that our consecutive interior angles are supplementary. So that means angles J and M would add to 180, and it means K and L would add to 180. So J and M, 180, take away our 87. That's going to leave us with, oops, type in the correct number. That's going to leave us with 93 degrees. So that means angle M is 93 degrees. Same thing on the right-hand side, 180, take away 51 from angle L. So 180 minus 51, 129. And that does make sense with the diagram because it does look like K is an obtuse angle and M also an obtuse angle, but it's not much past a right angle. Okay, number 2, angle R, we are asked to solve for. However, in number 2, you'll notice now we have expressions, but we can use the same ideas. So these two angles, Q and R, still have to add to 180 degrees, except now we need to write an equation for them. So 12x plus 3 plus 7x minus 13 equals 180. Combine your like terms. So I'll have a 19x. See, positive 3 minus 13 means minus 10 equals 180. Add 10 to both sides, so we have 19x equals 190. Very nice math. That means x equals 10. However, we still need to figure out angle R. So that means we need to take our answer for x and plug it back into our expression for R. So we're going to do 7 times 10 minus 13, otherwise known as 70 minus 13, or 70 minus 13 gives me 57 degrees. So angle R equals 57 degrees. Alrighty, example 3 now is an isosceles trapezoid. So that means it's very symmetric. So also too, all of our base angles or our pairs of base angles would need to be congruent. So just follow along the parallel line. If I have 47 at my x angle, following along the parallel line, that base of WX, that means this angle also has to be 47 degrees. But then I also know that my same side interior or my consecutive interior angles have to add to 180. So I also need to do 180 minus 47. So 180 take away 47, we have 133 degrees, and that will be the other base angles. Again, makes sense with the size of the angle. It is an obtuse angle. So that means angle W, 47 degrees, angle Y is 133 degrees, and angle Z, that's the other base angle down on segment ZY, so that's also 133. All right, so I'm going to leave problems 4, 5, and 6 for you to try out on your own, but they use the same techniques. Go ahead, pause the video and try those out. And then you can go back and look at those on your completed organizer. Alrighty, let's do 7 and 8. So again, number 7 is another angle problem. And so we know that this is an isosceles trapezoid. They tell us in the problem. So that means our base angles, the 2x plus 7 or 27 and the 5x minus 12, what do those measures need to compare to each other? They need to be equal. So let's do 5x minus 12 equals 2x plus 27. And again, the order doesn't matter. The reason I put the 5x on the left is because I kind of like having my x on the left-hand side. So I put the bigger x value on the left. Subtract 2x from both sides gives me 3x. And add a 12 to both sides gives me 39. Very nice math. Divide both sides by 3. We get x equals 13. However, this problem is also asking us about the measure of each angle, so I do need to plug these back in. I could plug it into either D or C. It doesn't matter. Let's use angle D to start it. So angle D would be 2 times 13 plus 27, otherwise known as 26 plus 27. See, in 20 plus 20 is 40. 6 plus 7 is 13. So we actually have 53 for that angle. And so I know that I have 53 on my two base angles because they're isosceles. So that's angles D and C. So 53 and 53. So how do I find my top two base angles now? Again, don't forget, consecutive interior angles always add to 180. So I need to do 180 minus the 53. So 180 minus 53 gives me 127. And again, makes sense with these obtuse angles to have 127. So both of those remaining angles are 127. So we haven't done too much with sides, so let's do a side example problem. And again, really the only thing that we're going to be able to do this with so much is isosceles trapezoids. And again, they have a nice symmetry to them. Their diagonals are always going to be congruent, as well as the sides are always congruent. So let's see what information they gave us and what we can do with it. So we are told that segment MP, we have an expression. So let's go ahead and highlight that. So there's segment MP. And then they say segment NO. Wait a second. How do those compare if this is an isosceles trapezoid? Well, those are going to need to be equal. So I know that I'll be able to say 9x plus 8 equals 16x minus 3. And again, it doesn't matter what order. You might want to put the 16 expression on the left-hand side to keep your x's positive. Okay, let's keep going. I want to make sure I understand all my info first. Let me change back over to purple. So now they're giving us segment PN, which is this one, and segment MO, which is this one. And what do you know about the diagonals in an isosceles trapezoid? They also have to be congruent. So we will also need to set those equal. So we could do 12y minus 37 equals 5y plus 19. The problem is asking us to solve for x and y, so we just need to solve those equations. So solving our first one, again, I would subtract 9x from both sides, so that's going to give me a 7x on the right. I would add 13 to both sides, gives me a 21 on the left, and that divides out very nicely. X equals 3. Then for our y, solving the other equation we wrote, subtract a 5y from both sides, leaves me with a 7y. Add 37, yeah, I need my calculator for that. That gives me a 56 on the right-hand side. And then dividing both sides by 7 gives me 8. Alrighty. So the last topic we need to talk about with these figures is something called a mid-segment. Now, before I go into what the mid-segment does and how it relates to our trapezoid, when you hear mid-segment, what other ideas come into your head? Well, we talked earlier this year about the midpoint, and the midpoint was perfectly in the middle of the two parts or the two endpoints on our segment. And it's a very similar thing for the mid-segment of a trapezoid, that it is going to be exactly in the middle of the lengths of the bases. So if EF is the mid-segment of the trapezoid, there's actually two things that we know. We know that E and F are midpoints, of AD and BC. So this means two things. This means that segment AE is congruent to segment ED, and it means that segment BF is congruent to segment FC. So on the sides, those non-parallel sides, they are perfectly cut in half. The second piece this means is because we have the mid-segment exactly in the middle of our two bases, well, think about what other ways that you could find the middle between two numbers. So if I have two values and I want to find the exact middle, I can actually find the average. And so that's what we're going to apply to this. The length of the mid-segment equals the average of the bases. So in other words, we could set up the formula, the length AB plus the length DC divided by 2 is going to equal the length of EF. And we would just plug the information we need into that formula. And it's just like we did with the midpoints. We took our X coordinates, add them up, divide by 2, take the Y coordinates, add them up, divide by 2. So again, let's look at a few problems. Again, anything with the red stars, again, I'm going to leave that for you to complete on your own for an extra practice problem, but I'll have that fully filled in the completed organizer right after this video. So let's look first at number 9. So in number 9, we have segment AB is 14 and segment DC is 26. Well, those are our bases. So that means our EF, which I'm going to go ahead and label as X, all we have to do is average our two bases together to make that mid-segment X. So 14 plus 26 divided by 2 equals X. So all we need to do is simplify that left-hand side. 14 plus 26 actually gives me 40. And 40 divided by 2 is 20. So the length of our mid-segment, EF, is 20. All right, number 10, exactly the same setup, just different numbers. And again, don't be worried if you get a fraction out, so you might get an uneven number divided by 2, that's okay. Again, life, unfortunately, is never perfect, so sometimes our math answers aren't perfect either. Okay, number 11. So number 11 is a little different. They gave us EF on this one. So EF is 22, DC is 38, and actually this has a mismatch. I will fix this on the version that I post online, but this should actually be find AB. And I'll fix that on the version that I post online, so you won't have my scribbled version on the original organizer. Alrighty, so I'm looking for segment AB. I need to find that value. Let's put an X there. So again, add your two bases, divide by 2, set it equal to your mid-segment. So in this case, we're going to have 38 plus X divided by 2 equals 22. Alrighty, how many of you actually like fractions? And they have their place, but they do tend to make equations a little bit messy. So let's undo it. If we're dividing by 2 on the left, how do you undo divide by 2? You just multiply by 2. So let's multiply both sides by 2. All it does on the left is cancels out the fraction, and it leaves us with the numerator, 38 plus X. On the right-hand side, we multiply 22 times 2, we get 44. And now all we need to do to solve for X, subtract a 38. So X equals 44 minus 38, otherwise known as X equals 6. And that is our length of AB. So same thing in number 12, looking for the missing base. Again, fill the X in for the segment that you're looking for. Write out your equation, and then get at that X. Move everything away from the X. Alrighty, let's try 13. So 13 is a little bit more involved here. So 13, you'll notice it has some variables in a couple places. We're still going to set it up exactly the same way though. So we're told Y and Z are midpoints. So that means I know I have a mid-segment and I can use the same formula. So take your bases. In this case, our bases are 38 and X plus 14. So I'm going to add those together and divide by 2. They equal the median. The median is 5X minus 19. Excuse me. So it looks a little scarier, but our system is, or our rules are the same way. If we don't want to have that fraction, let's go ahead and get rid of the fraction. Let's multiply both sides by 2. Now what we need to be careful of is when we multiply the right-hand side by 2, we are multiplying both terms by 2. It's the same sort of thing we looked at when we were solving proportions with similar triangles. So the 2's on the left cancel out, and we're left with 38 plus X plus 14. And on the right-hand side, it doesn't matter if we write the 2 ahead of the parentheses or after the parentheses, but either way, I know I'm going to have to simplify both sides. So on the left-hand side, I can combine my like terms. So 38 plus 14 gives me 52, so X plus 52, and distribute my 2 on the left, so I have a 10X minus 38. So ran out of room on here, so I need to go up to the next line. And let's see, let's go ahead and combine our like terms. I'm going to subtract an X from both sides. That will leave me with a 9X on the right. And then on the left, let's see, I have a 52. I need to add the 38 to move that one. So 52 plus 38 gives us 90. Ooh, that's nice, because now I know that X equals 10. So go back. I always check this on the problem. Are we done? Did we just have to solve for X? Unfortunately, on this one, we did have to solve for YZ. And so let's look for YZ on our diagram. Well, YZ actually is the mid-segment. There's YZ. So all I need to do is plug 10 into that expression. So YZ is actually going to be 5 times 10 minus 19, aka 50 minus 19. So that means YZ, let's see, 50 minus 19 gives me 31. Alrighty. So again, 14, red star, it's set up just like number 13. So I'm going to leave that one for you to do extra practice. So let's go down to our last problem, number 15. So again, same kind of scenario, wanted to do one more of these with variables in it. But again, let's just work with our formula and see where it takes us. So bases, 2x plus 11 and 6x minus 1, add them together and divide by 2. And that equals the midsegment. Actually, this one's even easier than 13 and 14 because I'm not going to have to distribute the 2 over anything on that right-hand side. I just multiply it by the 25. So multiply both sides by 2, cancels the 2 on the left. We're left with 2x plus 11 plus 6 minus 1 equals 50. And then I just combine my like terms. So let's see. Oops, I didn't copy down the x. There we go. So we have a 2x and a 6x, which add to 8x. We have positive 11 minus 1, so positive 10. So then subtract 10 from both sides gives me an 8x equals 40. Therefore, I know that x, I believe, is equal to 6, or nope, that's 5. And again, did they just want us to solve for x? Nope, they wanted us to find kj. So looking at my diagram, segment kj is 6x minus 1. So kj equals 6x minus 1, and we know that x is 5, so 6 times 5 minus 1, or 30 minus 1, aka kj is 29. Alrighty, again, I would highly suggest going back and doing the problems that we skipped over, but they are exactly like the examples. And then you are going to have a, let's see, looking at what we have scheduled for your trapezoid day. Alrighty, so you do have practice problems and a lesson check. But if you need extra help on any of these, call me back into your breakout room and we can check out any of the extra examples with the red stars. Let me know what questions you have.